Okay, so today we're diving into the world of AI again, but this time it's AI that designs computer chips. You know, those tiny little brains and everything these days.
Yeah, it's pretty wild. These circuits are so complex. It's like a puzzle with billions of possible solutions. Even for a simple circuit, it's mind-boggling.
No wonder humans need some help.
Yeah.
So how does AI even begin to tackle this?
Well, this system uses a transformer model. And no, we're not talking about robots turning into cars.
Although that would be pretty cool.
Definitely. But here, a transformer is all about algorithms and patterns. They can analyze these huge data sets of existing circuits.
So they're basically learning the language of circuit design.
Exactly, like some kind of superpowered code breakers. But instead of cracking codes, they're figuring out how to best arrange things like transistors and capacitors.
Okay, that makes more sense. But how do they actually get this AI to design from scratch? Is it just copying what it's seen?
That's where things get even more interesting. They actually took inspiration from AlphaZero, you know, that AI that plays chess and Go.
How could I forget? That was huge. But how does a chess-playing AI help design computer chips? It seems completely different.
It's all about strategy,
Yeah.
right? AlphaZero is like a grandmaster, learning to make decisions in these ridiculously complex situations.
So they took that strategic thinking and applied it to circuit design.
Exactly. Instead of chess moves, it's figuring out the optimal layout for circuit. It can actually explore possibilities, make trade-offs, come up with new designs.
So this AI is actually thinking strategically. That's amazing.
Yeah.
So how does that even work on a practical level? How do you explain a circuit to an AI?
So you have to break it down. Imagine this massive spreadsheet, and I mean massive.
Yeah.
It maps out every single possibility for the circuit. It's called a truth table.
A spreadsheet for every possible input and output of the circuit. That sounds incredibly complex.
It is, but remember, this is AI we're talking about. It can handle this crazy level of complexity.
So it's learning by example. It looks at these truth tables from existing circuits and then uses that knowledge to design new ones.
You got it. And here's where it gets back to AlphaZero and that strategic thinking we were talking about.
Yeah, the whole chess master thing.
Oh.
Yeah, the whole chess master thing.
The researchers realized designing a circuit is kind of like a game of strategy, too. So they took those core principles of AlphaZero, you know, exploring possibilities and making smart choices, and they applied it to this whole circuit design problem.
So short circuit is basically playing a game against complexity itself, trying to come up with the most efficient circuit design. So did it actually work?
That's the amazing thing. It did. They tested it on all these real-world circuits. And get this, in a lot of cases, short circuit actually designed circuits that were smaller than the ones designed by traditional methods.
Wait, smaller circuits? You mean like physically smaller?
Exactly. Smaller means less material use, so potentially cheaper electronics for us. But it's even more than that. Think faster processing speeds, less power consumption devices that last way longer on a single charge.
Wow. So this could completely change everything, from our phones to those huge data centers that power the internet, and all thanks to an AI that's basically a chess grandmaster. It's kind of hard to wrap your head around.
It really is. And the best part, they're just getting started. The researchers think short circuit could do even more to change the game of circuit design.
So you're saying this is just the tip of the iceberg. If AI can already do this, what else could it do? What other problems could it solve?
That's the question, isn't it? And it's not even just about AI replacing human engineers. It's about what happens when we put our heads together. Human ingenuity combined with the power of AI.
Humans and AI working together to design the future. That's getting pretty deep. But while we're on that topic, what about these designs themselves? I mean, how do we even understand the solutions this AI is coming up with?
That's another fascinating thing. These designs short circuit is making are so complex that even the researchers are having trouble understanding the logic behind them.
It's like trying to understand a language that only AI can speak.
Exactly. Like a glimpse into an alien intelligence.
Okay, that's both exciting and a little creepy, don't you think?
It's definitely a lot to take in. This tool can solve problems in ways we never thought possible. But it also makes you think, how do we understand this technology? How do we even interact with it?
It's like we opened this Pandora's box, but instead of unleashing something bad, we've unleashed all this incredible innovation. But how do we deal with that? What happens when AI is creating things that we don't even fully get?
Those are definitely questions we're going to have to answer as we move forward. It's a future full of possibility, but also a little bit daunting.
No doubt. Well, this has been an amazing deep dive. It really makes you think, if we're already struggling to keep up, what happens when AI leaves us in the dust? Like, what if we end up creating something so smart we can't even understand how it thinks?
That's a question that always comes up, doesn't it?
Mm.
Some people actually think that as AI gets more advanced, it'll become easier to understand.
Really? How so?
Well, imagine AI being able to explain itself, breaking down those complex ideas in a way that anyone could get.
Now that you mention it, I think I've heard that idea before. It's like AI becomes the teacher.
Right? Exactly. It could really open things up, make fields like circuit design make sense to everyone. But then again,
There's always another side to the coin.
right, and that's the thing. What if AI evolves in a way that we just don't expect? It might come up with its own ways of solving problems that we can't understand even if it tries to explain.
So we might create something brilliant, but have no idea how it actually works. A kind of black box.
That's the possibility. And it's something we really need to think about as we go down this road. It brings up all these questions about control, transparency, trust. If we don't get how an AI does what it does, can we ever really trust it?
Those are big questions. It's almost like we're back where we started. We've uncovered these incredible abilities of AI. It could change everything, but we still have a ton of questions.
And that's what makes it so fascinating, don't you think? This is really just the beginning. It's up to all of us to be a part of this conversation, to explore what's possible, but also watch out for the risks. We need to make sure we're building a future that works for everyone.
Absolutely.
Oh.
Well, this has been an amazing deep dive, to say the least. Who knew that AI designing computer chips would be so thought-provoking? It just goes to show the future is full of surprises. And the more we learn, the more we realize how much we still don't know.
Well said. I think that's a great place to leave it for today.
It sure is. Thanks for joining me on this deep dive, and we'll see you next time for another look at the world of AI.
Ever stop to think for a second about just how many computer chips we rely on every single day? Seriously, they're everywhere.
Kind of mind-boggling when you think about it.
Totally. In our phones, our cars, even our refrigerators.
Oh, yeah, those smart fridges that can, order groceries for you? Wild.
The world is seriously hungry for these tiny little powerhouses.
And that demand. It's exploding. No end in sight.
Which makes you wonder, how do they even keep up? Making a computer chip, that's going to be crazy complex, right?
It really is. It's like building a miniature city, but on a scale you can barely even imagine. Billions of components, all working together in perfect sync.
Okay, now you're just messing with me. Billions, come on.
No, seriously.
Yeah.
We're talking more transistors than there are stars in the Milky Way galaxy, all crammed onto something smaller than your fingernail.
Okay, that is mind-boggling. So how does that even happen? Where do they even begin?
Well, one of the trickiest steps in the whole process is something called logic synthesis.
Logic synthesis sounds intense.
Imagine taking something really complex, like a symphony.
Okay, I'm with you.
Now, try to write down that entire symphony note by note so someone else could play it.
Sounds like a recipe for a major headache.
That's essentially what chip designers are doing with logic synthesis. They take this description of what they want a chip to do, its functionality.
Right.
And then they translate that into the actual circuits, the nitty-gritty of how it all works.
So basically, it's like translating from one language to another, only the languages are like computer gibberish.
You got it. And it's a language that takes years of specialized training to master.
You're making me appreciate my smartphone a whole lot more right now, I'll tell you that.
Every time you send a text or stream a video, think of all those perfectly orchestrated circuits working behind the scenes.
It's kind of poetic in a way. But speaking of high-tech wizardry, that's where our deep dive today takes a fascinating turn. We're diving into a research paper that suggests maybe, just maybe, AI could design those circuits better and faster than any human ever could.
You're talking about ShortCircuit AlphaZero-Driven Circuit Design.
That's the one. It's causing quite a stir in the world of chip design. Apparently, this AI system can churn out circuit designs like nobody's business.
It's all thanks to something called AND-INVERTER graphs, or AIGs, which are kind of like blueprints for chips.
AIGs, blueprints. Okay, so walk me through this. What are we talking about here?
Picture a map of a city, a really, really complex one.
All right, I'm picturing it.
Now imagine the buildings in that city are like logic gates, the fundamental building blocks of any circuit. And the roads connecting those buildings, those are the pathways for information to flow.
So like a well-designed city makes it easy for traffic to move around smoothly.
Exactly. A good AIG does the same thing for information flowing through a chip. The more efficient that flow, the faster and more powerful the chip.
So what you're saying is the better the city planner, the better the chip.
Precisely. And that's why this short circuit research is so exciting. It's just that AI might be the ultimate city planner for the future of computer chips.
So how does AI even learn to design chips? Did they, like, send it to MIT or something?
It's actually a pretty cool two-step process. First, they use something called supervised learning, which is kind of like giving the AI a crash course in chip design.
So, like, showing it a bunch of examples and saying, do it like this.
Exactly. They feed it a massive database of existing AIGs, some better than others, of course.
Right, gotta have those bad examples too, so it knows what not to do.
The AI analyzes these AIGs, picks up the patterns, and learns the principles behind those really efficient designs. But here's where it gets really wild. Once it has that foundation, they hit it with reinforcement learning.
Wait, isn't that how they taught those AI systems to play Go and chess?
The very same. Only this time, instead of moving pieces on a board, it's experimenting with different ways to connect those logic gates, those buildings, in our city analogy.
So like a city planner trying out different layouts, seeing what works best.
Exactly. The AI is playing a game of its own, constantly trying to outdo itself, looking for the most elegant, most efficient design possible.
That's seriously cool. But how do we know it's not just making stuff up? Designing chips that look good on paper but wouldn't work in the real world.
Good question. To put it to the test, they use something called EPFL benchmarks.
EPFL benchmarks. Sounds kind of ominous.
It's actually not that scary. Think of them like the gold standard in circuit design, real-world challenges that chip designers face all the time.
Okay, so they threw some real-world problems at this AI to see if it could handle the heat.
Precisely. They wanted to see if it could hack it with the big leagues.
Did it? Spill the tea.
The results. Pretty mind-blowing. ShortCircuit was able to design AIGs for a whopping 84.6% of the EPFL benchmarks they threw at it.
Wow, almost 85%. But was it just barely scraping by, or was it actually coming up with good designs?
That's the thing. It wasn't just designing, it was innovating. On average, its designs were 14.61% smaller than those made by the industry standard software.
Whoa, hold on. Smaller, like physically smaller.
Yep. And often smaller means faster and more energy efficient, which is a win-win for everyone.
Okay, now my mind is officially blown. But what does this actually mean for, normal people? My grandma, who can barely work her TV remote. So smaller, more efficient chips. What does that even mean for our devices, though? Like, will my phone finally stop dying on me all the time?
Well, imagine this. Smaller circuits mean we can pack even more power into our devices.
Oh, okay, so we're talking even faster phones.
Exactly. More powerful laptops, too.
Right, now you're speaking my language.
And don't even get me started on the breakthroughs in artificial intelligence. That
Yeah.
stuff needs some serious processing power.
Right, AI, of course. It's like AI is designing the tools that will make it even smarter. Kind of freaky when you think about it.
It's a real game changer. For decades, humans have ruled the world of chip design.
Yeah, it's always been this superhuman thing to be able to do.
But now, AI is stepping in and, in some cases, even surpassing us.
That's pretty wild to think about. Like, if AI can already outsmart us in something as complicated as chip design, what's next? What else can it do?
It's a question a lot of people are asking. Imagine AI cracking the code for drug discovery or material science.
Oh, no, those are some big ideas.
Maybe you could even compose a symphony. Who knows?
You're blowing my mind here.
This research is opening doors we didn't even know existed. Doors to a world where AI isn't just helping us, it's leading the way.
It's exciting and a little bit scary all at the same time. Like, where do we fit in if AI is calling all the shots?
It's a good question, and there's no easy answer. But one thing's for sure. This new era of AI-driven innovation is here to stay.
So what you're saying is, buckle up. Things are about to get really interesting.
You got it.
Well, that's about all the time we have for today's deep dive.
Time flies when you're talking about the future of AI.
It really does. But we'll be back next time with another fascinating topic and more insights from our experts. Until then, keep those brains buzzing, and we'll see you on the next deep dive.
Ever notice how our smartphones, they just keep getting faster, every year, more powerful, like it's magic or something. But the thing is, it's not magic, right? It's all down to these incredibly complex chips, these chip designs.
Yeah.
But what if, and here's a wild thought, what if we could hand that mind-boggling task, like designing those chips, over to AI?
Right.
And not just AI that's okay at it, what if it was better than us? Better than humans at designing the brains of our devices?
Yeah.
That's what we're going to be diving into today.
Yeah, some really cool research out of Huawei's Noah's Ark lab.
Exactly. About this new AI system. It's called ShortCircuit.
It's a fascinating paper. It really gets at how we build like the almost the brains of our devices these days.
It's true. We all rely on chips
Right.
every single day, but most of us probably don't even think about what goes into them.
Yeah.
It's like we know there's a lot of tech crammed into those tiny little squares, but the actual design process, that's a whole other level.
Oh, yeah.
So before we get to the AI taking over part, can we take a quick dip into the whole chip design thing itself?
Absolutely, yeah. At its core, chip design, it really boils down to making these incredibly efficient circuits. Imagine like intricate mazes, right?
Okay.
With these things called logic gates acting like the crossroads, directing this flow of information. And the goal is to make these circuits as small, as efficient as possible, because the smaller and more efficient they are, the faster, the more powerful, the less energy our devices use.
Okay, so it's like we're designing the most efficient transportation system ever, but instead of moving people or cars, we're moving data.
Exactly. Exactly. But here's where it gets really mind-boggling. The number of possible ways to design even a simple circuit is astronomical.
Really?
Oh, yeah. We're talking about what's called a design space that is doubly exponential. It just explodes in size.
Doubly exponential. That sounds pretty intense. What does that even what does that even look like in real terms?
So imagine like trying to pick a winning lottery ticket
Okay.
where there are just billions upon billions of possible combinations. That's the kind of challenge we're talking about.
Right.
We're not even talking grains of sand on a beach. There are more potential designs for a simple circuit than like grains of sand on all the beaches on Earth.
Whoa. Okay. So this is not a task for humans, clearly. Or it's a task that would make a human's head explode, maybe.
Yeah, it's incredibly
You
challenging.
know, no wonder designing these things is so difficult. So how on earth can a computer, even begin to tackle this? It seems impossible.
All right, so chip design, crazy complex, even for like the most brilliant minds out there, right?
Yeah.
Which brings us back to ShortCircuit. This AI, it's not just trying to be a little bit better than us at this. It's like trying to crack the code in a whole new way. It's like going from designing a bicycle to, I don't know, a spaceship or something.
That's a good analogy. And what's really fascinating is how ShortCircuit actually approaches this challenge. It leverages a type of AI model called a transformer.
And you might have heard of transformers because they're the same technology behind things like ChatGPT.
Okay.
There's large language models that are all the rage right now.
ChatGPT, that's the one that can write poems and code, and
Yeah.
it's pretty amazing. But okay, how do you go from writing, sonnets to designing circuits
Yeah.
with logic gates and all that? It seems like a totally different ball game. How can something that understands language understand the language of circuits?
That's the ingenuity of this research, right?
Yeah.
So ShortCircuit doesn't jump straight from, poetry to circuits. It actually learns to design circuits in two distinct phases.
Okay, right. So 2 phases. It's learning time. Let's break it down.
Yeah. So the first phase is all about what we call supervised learning.
Yeah.
Think of it like giving ShortCircuit a massive textbook. Okay.
On circuit design, it basically devours tons of existing circuit examples. It learns the underlying patterns, the rules, the relationships between the inputs and outputs.
So it's literally like cramming for a really, really important exam.
Exactly. But here's where things get even more interesting. The second phase.
Okay.
This is where ShortCircuit transitions from student to master strategist, right?
Okay.
It enters the realm of what we call reinforcement learning, specifically using a technique that's inspired by AlphaZero. You might have heard of ALPHAZERO, this AI champ.
AlphaZero, that's the one that plays chess and Go, right?
Exactly.
And it just dominates, right? Those games with almost infinite possibilities, just like our circuit design challenge here.
Exactly. You got it. Remember that crazy design space we talked about with circuits? Yeah. Well, ShortCircuit basically plays a game against itself, using this reinforcement learning to really explore and master that space. It tries different circuit designs, it gets rewarded for creating efficient ones, compact ones, and it learns from its mistakes. So through this continuous process of trial and error, it becomes this master circuit architect. Okay, that's really cool. So it's we're giving it a sandbox, but it's digital, and we're just letting it go nuts and becoming this master builder. But the question is, does all this learning, does it actually lead to results? Can it actually design circuits better than what, human experts with all our years of experience can come up with? Okay, so ShortCircuit sounds like it's got some serious game, But does it actually, live up to the hype?
Mm-hmm.
Can an AI really design chips better than us? Like with all our years of experience and fancy degrees, can it really outperform humans?
Well, the researchers, they put short circuit to the test, like in the real world.
Okay.
And the results, they're actually really impressive. They gave short circuit 500 truth tables. Think of these like instruction manuals for specific circuit functions.
Okay.
And these truth tables, they were derived from 20 real-world circuits used in things like memory controllers, the units that do math in our devices, all that kind of stuff.
So it's like we're giving it 500 real-world design challenges.
Yeah.
And we're saying, all right, show us what you got.
Exactly, yeah.
Did it rise to the occasion?
It did, yeah. Short circuit consistently created circuits that were smaller than the ones that humans designed using traditional methods.
Okay, so it's beating out the old way of doing things.
Right.
Like, how much better are we talking? Is it just a tiny bit better?
Yeah.
Or is this a significant improvement?
It's significant, yeah. In some cases, short circuit even beat out a state-of-the-art design tool
Really?
called ABC by a considerable margin. Like, imagine shrinking those circuits by almost 15%. That's the kind of advantage that short circuit was demonstrating.
Wow, 15%. That's not just like a little win. That's huge. It's like going from driving a gas guzzler to an electric car in terms of efficiency.
Yeah.
But I guess for those of us who aren't, chip designers, what does this actually mean? Like, why should we be excited about this?
Well, this means faster, more powerful devices that use less energy.
Okay.
Imagine like your phone battery, right?
Yeah.
Lasting twice as long.
Yeah.
Your laptop booting up in seconds, and all while doing more than they can do today. That's the kind of future that this technology could enable.
Okay, that future sounds pretty amazing.
Yeah.
But zoom out with me for a second. Like, if AI can take on something as mind-bogglingly complex as chip design, what else could it do? Are we talking like AI designing everything? Like, could it design bridges? Could it cure diseases? Could it compose symphonies? Where does it end?
Those are all great questions. And while I can't predict the future, this research definitely opens up a world of possibilities.
It does feel like a watershed moment, like we're really on the cusp of something truly groundbreaking.
It's really exciting to think about where this could all lead. Like, imagine AI tailoring chip designs for very specific tasks. Making your phone even better at the things you use it for most. Or think about, like, just the accelerated pace of innovation, right? If AI is handling that really heavy lifting of chip design, it frees us up as human engineers to focus on the even more creative, those higher level problems.
It's like giving human ingenuity like a turbo boost.
Exactly. Yeah.
And here's a wild thought. What if these AI designed chips get so good that they actually help us build even more advanced AI in the future? It's like this crazy feedback loop of innovation.
No, that is a fascinating idea. It really seems like we're just scratching the surface of what's possible when you combine, human ingenuity with the power of AI. This research is just one example of how AI is really changing the landscape of what we thought was even possible.
Yeah. It really makes you think, if AI can design the chips that power our world, our technological world, what else can it do? What new frontiers will it unlock? Some food for thought. That's all the time we have for today's deep dive. Until next time, keep exploring, keep questioning, and keep an eye on the ever-evolving world of AI. All right, so get this. We're going deep on AI designing computer chips. The stuff that makes like our phones and everything actually work.
Right, the brains of everything.
Yeah, the brains of it all. And
Yeah.
this paper, what was it called? ShortCircuit AlphaZero-Driven Circuit Design. It really got me thinking, are we going to be seeing like human engineers working with AI instead of just like for them,
Totally. It's a really interesting shift, right? This research paper is really kind of like opening the doors to all this crazy stuff that could be possible when you combine AI and chip design, which is already insane.
Okay, yeah, hold the brakes for a second. I got to admit, I'm no engineer.
Sure.
What makes chip design so hard in the first place? I mean, they're not like drawing these circuits out by hand, right?
Well, they're not drawing them out by hand, but it's kind of similar to that in a way. Like, you could imagine it as building a puzzle.
Okay.
But instead of a picture, you've got like a goal.
Gotcha.
Like, you need to make the circuit as fast and efficient as possible.
I see.
And the pieces are like millions, even billions of these teeny tiny logic gates.
Logic gates, is that like the stuff I vaguely remember from computer science class back in the day?
Exactly, yeah, the fundamental building blocks of any circuit.
Oh,
And so arranging these logic gates correctly, which is represented in diagrams called AIGs, is like, it's basically like writing code, but it's like super complex and hyper efficient code, but it's with like actual physical components and the possible combinations. It's crazy. It's mind boggling.
Yeah, I can imagine.
It really is.
So I'm starting to see the challenge here, even with, even with computers helping design these things, actually finding the absolute best design out of, you said, billions of possibilities.
Yeah. Yeah.
That just sounds impossible, even for, like the smartest people in the world.
Right. And that's actually the core problem that this research is trying to tackle. Like, even with our existing methods, even when we use very sophisticated algorithms, they always hit a wall because of how complex it is, how many possibilities there are.
Right.
And that's where AI comes in, because it can process information in a totally different way and at a totally different scale than we can.
Oh, okay. That makes sense.
It can actually like learn patterns and...
Right. So it's like,
yeah.
So instead of replacing human engineers, it's almost like AI is becoming this like super-powered assistant that can help us explore these possibilities that we couldn't even dream of before.
Yeah, that's a great way to put it.
So the short circuit thing, this is where it comes in, right?
That's exactly right, yeah.
This is the AI assistant.
And it's remarkable how it like tackles this problem.
Yeah.
Like, it's not just trying every single combination.
Right.
It's smarter than that.
Okay.
It actually uses something called a transformer model. And this is a type of AI that's been making huge, huge waves in a lot of different fields lately.
Transformers, that's like the stuff behind like ChatGPT and all that?
Yeah, exactly. That's the same kind of underlying technology.
So instead of predicting like the next word in a sentence, this thing's predicting what? Logic gates?
You got it. Yeah, it's basically learning to speak circuit, if you will.
Right.
It analyzes all of these massive data sets of existing chip designs, and it figures out like, okay, this is what works, this is what doesn't work. And it builds up this like internal model of how all these logic gates can interact with each other.
That's amazing. Okay, that's mind-blowing. But how does it actually learn to do that?
Right.
We're talking about something way more complex than language, right?
It is really complex, but it's actually a two-step process.
Okay.
So they use supervised learning and then reinforcement learning.
Okay.
So imagine like teaching a kid how to ride a bike. First, you're showing them the ropes, you're putting on the training wheels. That's like the supervised part.
Gotcha.
And then you let them loose in a safe environment to just kind of figure it out themselves.
Yeah.
They're going to fall down. They're going to make mistakes. Right.
But they learn from it. That's reinforcement learning.
Oh, that makes sense.
Yeah.
So with short circuit, the training wheels, that's the data sets of all the existing designs.
Exactly.
Okay.
So it's analyzing thousands, millions of these circuits.
Wow.
Figuring out, okay, what works, what doesn't work.
Yeah.
And it's building up this like internal model in its AI brain about how logic gates interact.
And then they just let it loose to like design its own circuits.
That's the cool part.
That seems, I don't know, kind of risky.
Well,
what if it designs something totally crazy?
well, that's where the reinforcement comes in, right?
Yeah.
So it's not just blindly designing things.
Oh, okay.
It has a goal.
Okay.
The goal is to make the circuit as small as possible, as fast as possible, and as energy efficient as possible.
So every time it designs a circuit.
Yeah. It gets feedback like, hey, you did good, or hey, this one sucks.
Exactly. Yeah. Did it improve on the existing designs? Did it hit some new efficiency benchmark?
So it's like it's playing a game.
It basically is, yeah.
But the points are like efficient circuits.
Exactly. Yeah, you got it.
That's amazing.
It's really cool.
But even with all that learning, even if it like reads every circuit diagram ever, finding the absolute best design, that's got to be impossible, right?
You're right. It's usually impossible to know for sure if you've got the absolute best.
Right.
Because there's so many possibilities.
There's got to be like more possible combinations than there are stars in the sky.
It's astronomically large.
Yeah.
And that's where this other really fascinating piece of the research comes in. They actually use ALPHAZERO.
Wait, ALPHAZERO? Yeah. As in like the chess and Go playing AI.
The one and only.
What does that have to do with chip design?
That's the cool part. It's not just about playing games.
Okay.
What ALPHAZERO is really good at is navigating these huge, complex decision spaces.
Right.
It doesn't have to analyze every single possibility.
So it's not just trying every single combination.
No, that would take forever.
Right.
It explores strategically, it learns from every move it makes, and it starts to focus its energy on the paths that seem most likely to lead to success.
So it's like it's playing some crazy game with a billion different moves it could make, but the goal is to, like, I don't know, build the best circuit instead of checkmating the king or whatever.
Exactly. It's wild. And what's really cool is they actually showed how well this works in the paper. So they found that ShortCircuit was able to consistently create these circuits that were significantly smaller.
I mean, how much smaller are we talking here?
Like, on average, 14.61% smaller than the ones designed with conventional methods.
Okay, so 14.61%, that might not sound like a lot,
Like,
but
it's
in the world of chips.
Yeah, in the chip world, every, nanometer matters.
Totally. So that's like what? Shrinking down a smartphone chip, making it physically smaller
Yeah.
while it still has the same power or even more.
Yeah, or even better performance. And think about what that means.
That's huge, yeah.
Longer battery life, faster processing speeds.
Right, and it's all thanks to AI. That's wild.
All thanks to AI, yeah.
Okay, I'm convinced ShortCircuit is like, I don't know, it's the future.
It's pretty amazing.
Yeah. But I do got to ask, what does this mean for like the future of chip design in general?
Yeah.
Are we going to have like robots designing iPhones now?
I don't know about robots designing iPhones, but I think it's more about giving human engineers this incredibly powerful new tool.
Right, so not replacing humans completely.
No, definitely not replacing, more like collaborating.
Okay.
Like, imagine engineers, they set the goals, they decide, this is what we want the chip to be able to do, give it all the parameters.
Okay.
And then they let the AI explore all the different possibilities, like thousands, millions of them.
Oh, wow.
And it might come up with stuff that humans would never even think of.
So instead of spending years hunched over a desk staring at circuit diagrams.
Yeah, exactly.
Engineers can be more like, I don't know, like the architect.
That's a great analogy.
They come up with the blueprint, the idea, and they let the AI work out all the details.
Exactly. And that's where it gets really interesting, because now you've got this amazing collaboration between human ingenuity and artificial intelligence.
That's huge.
Imagine what we could do.
Yeah, I mean, are we talking like medical devices with AI-designed chips in them that can analyze complex health data instantly?
Exactly. Yeah.
Right.
Or you could have personalized learning tools that are way better than anything we have now.
Because they can adapt to how someone actually learns best.
Exactly. And all because the chips are smaller, they're faster, they're more efficient.
We might be able to solve problems that we didn't even know we had solutions to before.
That's what's so exciting about this. This isn't just a small step forward. It could be a total paradigm shift.
Right.
Changing how we think about technology forever.
Blurring the lines between what humans are good at and what AI is good at.
Exactly.
Well, this has been an incredible deep dive. And I got to say, I'm walking away with a lot more questions than I came with, but in a good way.
That's what we like to hear.
It's got me thinking about, what else can we do with AI?
Right. The possibilities are endless.
If it can help us design better chips, what else can it do?
Exactly.
I think that's something worth thinking about.
It really is.
And that's going to do it for this deep dive.
Yeah, thanks for having me. This was fun.
We barely scratched the surface here, and I'm sure you've got your own thoughts on all of this, so let us know what you think. Hit us up on all the socials, and until next time, keep on learning. Ever imagine a world where the only limit on computer chips is no limit? What if the design bottleneck just vanished?
Yeah, we're not just talking about making things a bit faster.
Today's deep dive is going to blow your mind. We're talking AI, designing AI, specifically AI that can create the circuits that make computer chips tick.
It's fascinating. This research hints at a potential paradigm shift in how we develop the hardware that powers, practically everything.
Okay, so let's unpack this. Our source material for this deep dive is a research paper with a catchy and kind of intimidating title, ShortCircuit AlphaZero-Driven Circuit Design.
Catchy title, for sure.
Don't worry, we'll break it down.
The core issue this paper tackles is how immensely complex chip design is, particularly creating those tiny but critical pathways called circuits.
Right, because it's not as easy as just connecting point A to point B, right?
Yeah, not at all. We're talking about optimizing for speed, power consumption, size, all at once, in a microscopic space.
Yeah, they're tiny.
The research paper actually uses the analogy of a chessboard, but with more possible moves than atoms in the universe.
Whoa, okay.
Just to give you a sense of the scale.
Yeah, no, that's mind-bogglingly complex.
Yeah.
So how does this short circuit system even begin to wrap its metaphorical AI brain around that?
So it starts with something called truth tables.
Okay.
And stick with me here. They're basically a way to lay out all the possible inputs and outputs for a circuit, like a logic map.
Okay, so that's how we're defining the problem for the AI.
Yeah.
But the AI itself, what's the special sauce in short circuit?
They use a couple of really interesting approaches. First, there's this powerful type of AI called a transformer. You might have heard of these from language models, like the ones that power those really human-like chatbots.
So they took something designed for understanding language and applied it to circuit design. That's pretty wild.
Yeah, it's a really cool example of how adaptable these AI tools are becoming. But it gets even more interesting. ShortCircuit also uses a strategy borrowed from ALPHAZERO, the AI that's famous for mastering games like chess and Go.
Wait, game-playing strategies for designing the guts of a computer chip? That is some serious out-of-the-box thinking.
Exactly. And the researchers show how they trained ShortCircuit using real-world circuits from something called EPFL benchmarks.
Okay.
These aren't just theoretical exercises. They're circuits that do real tasks, like arithmetic calculations.
Got it.
The paper specifically mentions square root calculations,
Makes sense.
or those used in control systems.
Okay, so they're giving short circuit a solid education in how good circuits are supposed to work. But how do you go from training to actual design? That's got to be a huge leap.
It is a huge leap. You're right. It's a two-step process.
Okay.
First, there's pre-training,
Right.
where ShortCircuit goes through this massive data set of existing circuit designs.
Yeah.
It's kind of like learning the basic grammar of circuit creation.
Circuit Design 101 for AI. I like it. Then it's got to graduate to something more advanced, right?
Exactly. That's where fine-tuning comes in. This is where that AlphaZero inspiration really really shines. Instead of just copying what it's seen, ShortCircuit starts to experiment, trying out different designs.
Okay.
But it's guided by those same search and optimization principles that make AlphaZero so good at, well, games.
So it's like giving the AI a playground to experiment in, but with some really smart guardrails, to keep it on track. So the big question is, did it actually work? Can this AI really design circuits that are as good as or even better than what human engineers can do?
The results are really promising.
Okay.
The paper shows ShortCircuit wasn't just able to design circuits that work.
Yeah.
They were often smaller than the ones designed with more traditional methods.
Okay.
And in the world of chips, smaller is definitely better.
Right.
Less material, less power consumption,
Makes sense.
all leading to more efficient tech.
Okay, so smaller circuits, that's a win.
Oh, wow.
But how much smaller are we talking? Like, were there any aha moments where short circuit just blew the doors off the competition?
There's one example they highlight that really caught my eye. ShortCircuit was able to get a 14.61% size reduction compared to a standard circuit design tool. It's called ABC.
Okay.
14.61.
All right, so I'm picturing these tiny circuits, but help me connect the dots here. What does a 14.61% reduction in size actually mean in the real world?
Think of it this way, even what seems like a really small gain in efficiency can have huge ripple effects. It's like, shaving fractions of a second off a lap time in, like, Formula One racing.
Right, those tiny margins matter.
Exactly. Those tiny margins can be the difference between, winning and losing.
So faster, more powerful chips that use less energy. Is that what we're boiling this down to?
You got it. But it's not just about making our current devices, a bit better. What's really exciting is that this breakthrough could change the pace of innovation.
Okay.
Right now, designing and optimizing a new chip can take months, sometimes years.
Yeah.
But if we have AI like ShortCircuit in the mix, who knows how much faster we could move.
That's wild. Like, imagine the possibilities if we could cut down chip design time from years to months or even weeks.
Yeah.
But this all begs the question, what happens when AI can do this for any type of circuit? This research focused on a specific type, but what's the next step? Could ShortCircuit eventually design the chips that power, say, quantum computers?
Now, that's a question that gets researchers like me really excited. We're talking about pushing beyond the limits of what we even thought was possible,
Right.
Imagine AI not just optimizing what we already know, but helping us explore those what-if technologies that seem like science fiction today.
Okay, so we're venturing into mind-blown territory here, but let's bring it back down to earth for a sec.
Oh.
If AI can potentially design the hardware, the software, maybe even write its own code, what does that even mean for the future of, human chip designers?
It's a question worth asking for sure, but I'll be honest, I see it as an incredible opportunity. Look, designing circuits, it's a demanding job, it's complex, and as we've discussed, it's incredibly time-consuming. What if, instead of replacing us, AI took on that heavy lifting?
You're saying AI could free up human engineers to focus on the bigger picture, like the more creative, strategic side of things.
Yeah, precisely. Imagine partnering with an AI that can just rapidly prototype thousands of options, explore all sorts of wild new architectures, while you, the human, focus on the high-level goals. It'd be like having a superpowered assistant that lets you focus on the why instead of getting bogged down in the how.
I love that. AI as a creative partner, enhancing our own ingenuity. So to sum it all up, it sounds like AI designing computer chips, it's not just a cool idea anymore. It's a field that's producing real results with the potential to revolutionize technology as we know it.
Absolutely. This research, it's really a glimpse into a future where the pace of technological advancement could accelerate dramatically, and who knows what incredible breakthroughs might be possible when we unlock that kind of potential.
And on that note, we'll leave you with this thought. If an AI can design a more efficient circuit than a human can, does that mean it's smarter? Or is there something unique, something inherently human about our creativity, our ingenuity, that AI might never fully replicate? Something to think about. Until next time.